All right, class, welcome to the TJ Math 8 Unit 2 CSA Review and Corrections. We're going to use this PDF. Okay, so this will be uploaded onto YouTube shortly, and you can use your own paper if you don't have access to a printer. All right, it is December 3rd, Tuesday, December 3rd. 2020. Question 1. Solving for x. Now, I've put a few things into this test as I clipped out the problems. So you did not see this when you were taking the test. Here we have solve for x. Well, how do you do that? You first check to see if you have to use a distributive property. And you go over here and you say, oh, this is parentheses, multiplication, distributive property. So you have to do that first. Where we do 2 times x is 2x. 2 times negative 4 is minus 8. We saw earlier where you can also change that to plus negative 4 because the term itself is negative 4. 6x plus 8. Next we go to, there's no more distribution. Second, can we combine any like terms on the same side? Well, let's take a look. We have a variable term and a constant, so nope. We have a variable term and a constant on the right, so those are not like terms. So we're not going to do that. Only if they're alike would you combine them. And then we finally end up with inverse operations being the third thing that we have to do. So we have a variable term on the left and the right. We choose to collect the variable term either left or right. And if at all possible, a lot of times it's easier to work with the positive. So if I would, in that case, subtract 2x from both sides. I would draw a vertical line and an addition line. So then I work the problem vertically down the page. 2x minus 2x is 0, but I don't write 0, I just cross it off. I bring down the constant because nothing happened to it, the equal sign. And I have, oops, careful with the sign, minus 2x. 6x minus 2x is 4x. And nothing has happened to this constant. It's still plus 8. So we collected variable terms. A little bit more complicated. Now we're left with a two-step problem. Our goal is to get x by itself. We're doing inverse operations, SAD map, which tells us to do subtract and add first. The only thing we subtract or add is this constant. We subtract 8. And this is a little tricky. Doesn't that look like it would be 0? But it's not. We're combining negative 8 plus another negative 8, or negative 8 minus 8. But when we combine both negative 8s, we get negative 16. 4x comes down. 8 minus 8 is 0. So we're almost done. We still have the equal sign. When the coefficient's an integer, it's easiest to divide by 4 instead of multiplying by a reciprocal. 4 divided by 4 is 1x, or just x. Negative 16 divided by 4 is negative 4. We're almost done. We do need to check your solution. We have to substitute your solution for x. So here's the equation. 2, and our answer was x equals negative 4. So in place of x, we're going to put negative 4 minus 4. 6 times negative 4 plus 8. Do inside the parentheses under order of operations. So we're going to do 2. Negative 4 minus 4 is negative 8. We're combining the two negative 4s. 6 times negative 4 is negative 24. Plus 8 Now we do some math here. 2 times negative 8 is negative 16. Negative 24 plus 8 is negative 16. And we've successfully checked our answer. Again, this will be on YouTube, so if you don't get everything, that's fine. I'm going to push it up just a bit. Question 2, we have using angle properties, write an equation that could be used to solve for the unknown angles. All right, so here we have the situation, and we're looking at this is let me choose a color here. Let's say I'm looking at this relationship. I'm looking at this angle here. Here's an angle. It starts here initially, terminates here. And then this angle, if you look at it, goes this direction. Oh, this should go a little higher. Okay, it's a little bit. 1, 2. So I'm making 2 lines because it's a different, unique angle. Here's this angle. And what do I notice about both angles? I notice that both angles together form a semicircle. Well, I know a full circle is 360 degrees. So what is a semicircle? 180 degrees at the center, measured from here, of course. What does that mean? If I look at the red again, if I take this red angle plus this angle, it's going to add up to 180. That helps me write my equation. This angle says it's 12x minus 5 plus 10x plus 15. When I add those together, it adds up to the full semicircle. Okay. Well, now I have some like terms. What do I have to identify the like terms. The like terms I need to identify. The variable terms, I put single line under the variable terms. And I'm going to put 2 lines under the constant. So that way I don't combine things that are not alike. 12x and 10x is 22x. Negative 5 plus 15 is plus 10 equals 180. Oh, and now I remember what I did last class, that when I ended up being, oh, okay, I subtracted 10, but it doesn't say I need to solve it. It just says write an equation that could be used to solve, which is this guy right here, or this one. You can stop right there. You don't have to solve it. If you do solve it, you end up with 22x equals 170, and you divide by 22. You get a really, I think it's 7.72. Yeah, repeating. So it's rational because it repeats, but it's rational because x equals 170 over 22. But this was the answer here. This or this. Okay, so you could stop at either. Question 3, solve for x. Again, we have to go through, how do you solve for x? Well, we solve for x by doing one of 3 things. Well, we do 3 things. Distribute if necessary. Okay, let's do that first. I'm going to draw this distribution arrows because I'm multiplying. 2x minus 10, because it's 2 times negative 5, equals. And then I have a lot of things on the right. So I'm actually on the right, I'm already at the second thing, combining like terms. I just have to identify like terms. I have a variable term here and here. So I used a single underline. Then I have constants here, 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 and here. I have 4 constants. So if I combine the variable terms, negative 3x plus 3x, that's going to be 0x. And then 9 and 6 is 15, 23, 30. Okay, well, I don't write 0x if there's nothing there, so I'm going to rewrite this as 2x minus 10 equals 30. And now I have a simple 2-step equation that you guys have had so much practice with. I'm going to add 10 to both sides, make my line here so I stay on the right side, bringing 2x down, equals 40. This is simple enough I can use mental math. If 2x is 40, then 1x is half that. It's 20. I didn't ask you to check your work on that one, so we did do inverse operations. We did that third. Next comes the hardest problem on the test. Oh, like I know that I have asked to go a little slower. This will be posted on YouTube later. All right, sorry. Let's go to question 4. Well, I'll leave this one up as much as possible. Okay, I'll slow down a bit. In question 4, we have something that says find the length of the rectangle, and you're given the perimeter of a rectangle is 44 inches. So we have to first start thinking, well, what is the perimeter of a rectangle? And the easiest way to look at it is to start at one point on the rectangle and then travel in all 4 directions around the outside. So I travel, if I start here, I travel up a width, then I turn to the right and I travel the length of the rectangle, then I turn down and I travel a width, and I travel until I get all the way around. That's the perimeter, which equals 44. I travel one more length. So if I think about what I've done, the perimeter is equal to, what was it? The width, I traveled the width, plus a length, plus the width, plus the length. So I happen to know that the perimeter is 44 inches. So I can change the word perimeter to 44. And then I have some more information given. The length, the L, is related to the width. The length is 5 inches, 5 less than double the width. So for my length, it says it's going to be 5 less than double the width. So let me think about what that is. The length is equal to minus 5, but to double the length, the width. Double the width minus 5. Okay, so I have a relationship here. I know what L is. I can take that value of L, and instead of writing L, I can change the L's. I can change them, each L, to 2W minus 5. And I don't do anything to this W, but I am going to change each L to 2W minus 5. And this one's going to be 2W minus 5. So I have a pretty manageable problem now. Make sure that you combine only alike terms. That means the variable terms are alike. And then separate of that is the constants. They're not alike. So we need to count up our W's. 1W plus 2W is 3W. Plus another W is 4W. Plus 2 more is 6W. And then we have combining -5 and -5. That's -10. We're really close now. We just have a two-step problem left. We have practiced so many times that we know we attack that constant first by adding 10 to both sides. The addition bar, because that's what we're doing, adding and subtracting. 54 equals 6W. This is gone. We're really close to the end. If we divide by 6, we get W equals 9. Man, I feel like I'm done. Oh, wait. Uh-oh. Find the length of the rectangle. I didn't find the length. I found the width. But I do know how the length and the width are related. So I know that the length is equal to 2 times the width. 2 times 9 minus 5. 18 minus 5. If I want to check if that's right, you don't have to check. You can just watch. It's 9, 13. 9 and 13 is 22. And 9 and 13 is another 22. So 22 and 22 is 44. Question 5. Now, again, in your test, you wouldn't have seen this. This is your essential question. I know, I'm sorry, man. I have to keep the video under a certain number of minutes. Sorry. Linear equations can have one solution, no solutions, and infinite. And now we're looking for each linear equation in the table. That's these right here. There's 3 of them. The table got a little messed up, sorry. You want to find out if they have no solution, one solution, or infinitely many solutions. A lot of you got this one right, which is awesome. So we had this answer. We practiced it. Linear equations can have one, no, or infinitely many solutions. Let's go through the cases. Let's go through backwards. If the coefficients are the same and the constants are the same, you have infinitely many solutions. Okay, so this is for infinite. If the coefficients are the same and the constants are different, then there are no solutions. That's no. And if the coefficients are different, then there is one solution. Wow. Let's go through and see kind of the easy. Let's look at this. Let's go look at it from the back. Let's look at this problem where we have the constants are different, and here's the coefficients, -4 and +4. Those are not the same. The coefficients are not the same. Which of these? Case 3 says if the coefficients are the same. Case 2, but case 1's the one that says if the coefficients are different, one solution. Coefficients are different, one solution. Let's look at this one. This one, the coefficients are the same, 1 and 1. So we're dealing with either case 2 or case 3. After we know the coefficients are the same, we go move over here to the constants. -3, +3. Okay, well that means that the constants are different. Which of these says the constants are different? Oh, that's case 2. Coefficients are the same, constants are different. No solution. Now I'm over here. Hey, look, the constants are the same. Maybe this is infinite. Now I need to look at the coefficients. This has a 5x. Uh-oh. There's no x's over here. 0x. That means the coefficient is 5. The coefficient here is 0. That's coefficients are different. That's where people got a little bit tricked. This was one solution. So if you're playing at home, you just need to write the equations down and the answers here. But it's a good idea to know why. Question 6. Again, this don't show up. Solve for x. Show your steps. Solving equations using distributive property combined with terms. So first is distributive. (12x minus 6 equals 4 plus 7x). Now I have can I combine any like terms? The variable term and constant, no. Constant and variable term, no. So we're not doing that. But I do need to do inverse operations. I have variable terms on both sides. I got to collect them on one side, so I'll do that. Minus 7x. Okay, 12x minus 7x is 5x. Nothing happened to the constant. This is gone. Now I'm at a two-step problem. I deal with the constant first here. I add 6. Bringing down 5x equals 10. I can use mental math at that step. X equals 2. And check your answer. You have to substitute it in. I have some resistance in this class sometimes. 6 parentheses 2 times 2 minus 1 equals 4 plus 7 times 2. So I'll do inside the parentheses. I got to do multiplication. Before I do subtraction, I got to do multiplication inside. 6 times 4 minus 1 equals 4 plus 7 times 2. Now I can do the subtraction. I don't multiply. You could distribute, but inside the parentheses, you can combine these. So it tells you that under normal order of operations, you are doing inside the parentheses first. So that's why it's 6 times 3 equals 4 plus 7 times 2. 18 equals 4 plus 14. 18 equals 18. Check. So we are halfway through the review of Unit 2. Again, this will be on YouTube later, so you can just queue up to the point where you might have missed one little thing. It goes a little faster from here on the test. triangle angle properties. We brought back in some Unit 1 concepts to this test where we've already learned that we're going to use the triangle properties. We're going to write an equation to solve for x. So when you look at this triangle, you have to recognize that this is the interior of the triangle, and this is the exterior of the triangle. It's actually an exterior angle, and we know that is equal to the sum, that's plus, of the remote, that's far away, interior angles. So we have these far away angles. This angle here and this angle here are far away from this angle, outside angle. Okay, so that we're going to use that over here. The exterior angle, 136, is equal to the sum of the remote interior angles. It's going to be combined with a plus. We have 9x plus 16 plus 6x plus 15. Now that would have got you the first point. We have to simplify because the question 8, you have to find the angles. So make sure you're combining like terms. Variable term, constant, constant. 136 equals 9x and 6x. It's 15x. 16 and 15 is 31. It's just a two-step problem from here. Subtract 31. And you end up with 15x equals 105. And if I grab my calculator and I divide 105 divided by 15 is 7. Remember, we divide by the coefficient. 7 equals x. So we know it's 7, so we need to find angle A. Angle A is equal to 9 times 7 plus 16. That's 63 plus 16. 79 degrees. And angle B is equal to 6 times 7 plus 15. That's 42 plus 15 is 57. Just slightly after lunch. So make sure, check it, that 79 degrees plus 57 degrees, that's 120, 136. It does check. Question 9 was probably the easiest question on the test. Solve the linear equation. You just have to look. So we're looking under case 1. Coefficients are different. That's one solution. Case 2, coefficients are the same. Constants are different. That's no solution. If both are the same, we have infinite solution. So we look here that we starting off, both coefficients are -7. So the one solution is, it's out of here. And now we just go to the constants. The constants happen to be different. So that means there's no solutions. That was a lot of people got that one right. So congratulations if you got it right. This was also a relatively easy question here. Again, this wasn't on. This was in your notes. These this essential answer. This one says, what option would you create an equation with infinite solutions? So let's take a look. We need coefficients the same, and the constants are the same. Okay, so let's simplify this thing on the left here. There's a parentheses here, but there's nothing in front of it except for a 1. So this is going to stay the same. Excuse me, 2c plus 3c minus 4 equal to this. So we can combine the like terms. That's 5c minus 4 equals square. Excuse me. So the constants minus 4, and then it says the coefficients have to be the same. Excuse me. Okay. Those were all worth 1 point. And then it got to our essential question. A lot of people got essential question 1 correct. It was worth 2 points. It was pretty simple. We've talked about it a lot of times. How do you solve linear equations? It's pretty simple. We do 3 things. We use 1, distributive property. Then we use combine like terms. And we finish with inverse operations. This answer got you 2 points. And then a little harder was 12. Not the first point. A lot of people got the first part. What are the possible solutions to a linear equation? Most of the class got 1 solution, no solution, and infinite solution. Sorry. That got you 1 point right there on the rubric. But then it says, how could you determine the number of solutions without solving the equation? It's not as complicated as you might think. For 1 solution, if the coefficients are different, if the coefficients on each side are different, then you have 1 solution. The other 2, the coefficients are the same. After you have the coefficients being the same, excuse me, you have to look at the constants. And the difference between the two, in the no solution, the constants are different. And in the infinite, the constants are the same. Because they're identical on both sides. We called it an identity. Well, I appreciate you guys taking the time to watch this walkthrough of the CSA retakes. Get it uploaded as an assignment, and I'll get it on YouTube.